Okay, now let's use this idea in reverse. So this question says the sine of theta, some angle, is equal to the square root of 3 over 2. So what we're going to do is look back in our table, say, okay, well, sine is square root of 3 over 2. Let's look down here and see what we can find. So here's my sine column. Looking through, looks like I've got a square root of 3 over 2 there, square root of 3 over 2 there, square root of 3 over 2 here, but it's negative, so that's not it. Not that one either. So it looks like it's 60 and 120. That's what the table is telling us. Table says that if the sine of theta is square root of 3 over 2, then theta was either 60 degrees or 120 degrees. That's pi over 3 or 2 pi over 3. You should probably get in the habit of converting those as often as possible. Okay, this next one now says the sine of theta equals negative square root of 3 over 2. So now we're going to go back to those other ones and say, okay, now we're looking for those ones that are negative, which was this one and this one, 240 and 300. So we would say in this case, theta equals 240 degrees or 300 degrees. That is 4 pi over 3 and 5 pi over 3. Simple enough, yeah? Yeah. Okay, let's do cosine. Cosine of theta equals negative square root of 2 over 2. Okay, looking in our cosine column here, square root of 2 over 2, but it's not negative. There's a negative 1. There's a negative 1. This one's not negative, so it's going to be 135 and 225. 135 and 225. See, that's 3 pi over 4 and 5 pi over 4. Okay, this last one says tangent of theta equals negative 1. Okay, looking back at our table, and you might already know these. Tangent equals negative 1. Looks like that happens here and here. So 135 and 315. 35 and 315. So the whole idea with this is that you're trying to do it backwards now. Instead of me saying, oh, find the tangent of 3 pi over 4. Now I'm saying, hey, I'm giving you the value. I want you to tell me what angle it was that I had plugged into my trig function. And that's what this whole solving an inverse trig functions is about. So notation. Inverse trig functions, right? So for the sine function, this right here is the most common notation for an inverse sine function. F inverse, right? You've seen that little negative 1 before when we've talked about inverse functions. But that's all it's saying. Another way of writing it is called arc sine, and you might see that, so I throw it in there. It is on the worksheet and that stuff. Basically, it's exactly what we just did. If this is true, the sine of theta equals y, then your angle is the inverse sine of y, which means find the angle whose sine is equal to y. Now that wordy stuff, here's an example. If I tell you that the sine of theta is 1/2, then theta is equal to the inverse sine of 1/2, which would be, hey, let's go look back in our table. Looks like for 1/2, it's at 30 and 150. So you would say that theta equals 30 and 150. Okay, same thing for cosine. Looks very, very similar. That little negative 1 means inverse, or the word arc might be in front of it. Same exact thing. If you tell me that the cosine of theta, some angle, equals a number y, then you're asking me to find the angle whose cosine was that value. For example, if I tell you the cosine of theta is negative square root of 3 over 2, okay, back in our little table here, I need to figure out what the theta was that made it negative square root of 3 over 2, like we were just doing. So 150 and 210. So this one said theta was 150 degrees or 210 degrees. Okay, same thing with tangent. Tangent -1 up in the powered looking thing, inverse tangent, or it could be arctangent. Same thing. If I tell you this, then this is the question that I'm asking. Which angle was it that when I found the tangent of it, it equaled this number? So this one says, okay, tangent of some angle equals -1. What is that angle? Well, according to, let's see on this last one, huh? It was 135 and 315. 135 and 315. Notice here that I use arctangent just to make sure you recognize that it can be written as either way. You just have to remember what they mean. And honestly, that writing that part down can probably be skipped. All I'm curious about, or all I'm looking for, is the angles. Let's try some. It says find the exact value or values of each of the following. So arc sine, inverse sine of -1. That means I need to find the angle whose sine was equal to -1. All right, let's look back at our information. Okay, so -1 though, our original table right here, there's no -1s for sine. That was one of our quadrantal angles. So looking in here, it looks like at 270, the sine is -1. That's it. That's the only one. So theta equals 270 degrees or 3 pi over 2. The worksheet that goes with this is asking for the answers in radians to try and get you to go back and forth again. So I'm just going to write these down as I go, and I mean, some of them will be done for you. Next one, inverse cosine of -1/2. That means that the cosine of theta was equal to -1/2. And what I'm trying to find is the angle where that happened. Table says cosine -1/2 at 120 and 240. -120, whoops, negative, 120 and 240. That is 2 pi over 3 and 4 pi over 3. Okay, inverse tangent, square root of 3. That means the tangent of some angle was equal to the square root of 3. Okay, now we got to figure out what that angle was. We're going to go back to our table here. Tangent square root of 3 positive was 60 degrees and 240 degrees. So 60 degrees, which is pi over 3, and 240, which we already decided was 4 pi over 3. Okay, next one. If I ask you to find the inverse sine of square root of 2 over 2, that means that the sine of some angle was equal to the square root of 2 over 2. So I'm trying to find that angle. That means theta equals, this one I know by heart, it's 45. The square root of 2 over 2's are easy, and since it's positive, it's going to be in quadrants 1 and 3. So you can look back at the table if you need to. It's going to be at 45 and 135. It's pi over 4 and 3 pi over 4. Okay, this one says arc cosine. That means that the cosine of some angle equals 0, and I need to figure out what that angle is. Now it's a 0 with cosine, which means we're only going to go back here to the quadrantal ones. Looks like it happens at 90 and 270. So our answer here is theta equals 90 degrees or 270 degrees. That's pi over 2, 3 pi over 2. Okay, inverse tangent is 1. Again, looking at your table here, inverse tangent is 1 happens at 45 and 225. So theta equals 45 and 225. Whoops. This meant the tangent of some angle equaled 1. That is pi over 4 and 5 pi over 4. Okay, so that's kind of this whole idea of inverse trig functions, and it's leading up to what we're doing when we're solving. Now, of course, there are their buddies. If I asked you to find the exact value of the cosecant, the inverse cosecant of -2, then you have to think a little bit about it. Now, remember that sine and cosecant are buddies, which means they're reciprocals. So if this one said the cosecant of some angle was -2, that means that the sine of the angle was -1/2. Does that kind of make sense? They're buddies, right? So if I'm asking you for the arc cosecant, inverse cosecant of -2, that's when the sine of some angle was -1/2. Reciprocals, right? Reciprocals. Buddies. So now I'm trying to find the inverse sine of -1/2. So theta equals, look back at our table, -1/2 happens at 210 and 330. So the answer still for this original problem is going to be 210 and 330 degrees. Pi over 6, 7 pi over 6. So you just got to implement the whole reciprocals thing. For example, this one would be the same thing as the inverse cosine of 1 over square root of 2. If you rationalize that, that's actually square root of 2 over 2. And then you look at your table and you say, okay, that happens at 45 degrees and 315 degrees. So pi over 4, 7 pi over 4. Secant, cosine, buddies. Flip it around, do the reverse, the reciprocal, sorry, and it's the same problem. So inverse cotangent means the cotangent of some angle was the square root of 3, which means the tangent of that same angle was 1 over square root of 3, or square root of 3 over 3. Okay, looking at our table, we find that that happens at square root of 3 over 3 positive was 30 degrees and 210. So 30 degrees and 210 degrees, or pi over 6 and 7 pi over 6. Okay, inverse trig functions. That's what we're going to use to help us solve these equations. So let's practice.